Pure Mathematics, Paper 1, Advanced Subsidiary, Wednesday, 16 May 2018. Answer all questions and ensure that your answers to parts of questions are clearly labeled. You should show sufficient working to make your methods clear. Answers without working may not gain full credit. Question 1. Find integral of 2 over 3x cubed minus 6 square root of x plus 1, giving your answer in its simplest form. So to integrate, we would write integral of 2 over 3 x cubed minus 6 square root of x. We'll write it as x to the power half plus 1 dx. So when we integrate, we add 1 to the power and divide by the new power. So it's x cubed plus 1, 3 plus 1, and divided by the new power, which is 3 plus 1 is 4. So it's 2 over 3 times x to the 3 plus 1 over 4 minus 6 x to the half plus 1. You add 1 to the power. Half plus 1 gives you 3 over 2, and you divide by 3 over 2. Plus integral of 1 is just x, because integral of a constant is like 1x to the 0. So you add 1x to the 0 plus 1 divided by 1. It gives you x to the 1 over 1, which is x. Integral of 1 will just give you x plus the constant c. And now you simplify. 2 over 3 times 1 over 4, it gives you 1 over 6. So x to the 4 divided by 6 minus 6 divided by 3 over 2, which gives you 4 minus 4x to the 3 over 2 plus x plus c. So that's your integral. Question 2. Show that x squared minus 8x plus 17 is greater than 0 for all real values of x. So what you want to do is you want to complete the square. So find half of 8 is 4, and if you square it, it will be x minus 4 all squared. So you would write it as, you will have x minus 4 times x minus 4. That will give you x squared minus 8x plus 16. So since we just want x squared minus 8x, we will have to minus 16, and then we would add 17. Minus 16 plus 17 is 17 minus 16 is plus 1. So x minus 4 all squared plus 1. So that gives us x minus 4 squared is always positive, as it is a squared number. And that shows, and when you add 1, the answer is always greater than 0. And if you put it in your calculator and you plot the graph y equals to x squared minus 8x plus 17, you will see that it's above 0. X, the minimum point there, is above 0. So it's shown that the minimum point is 4, 1, and it's above 0, and you've done it algebraically. And when you do it in the graph, you will use minus 4 as a minimum point for as a x minimum, and 10 for x maximum, and 0 for y and minimum, and 20. That will show it clearly. Another way to do it, you differentiate dy over dx. When you differentiate x squared, you get 2x. You differentiate 8x, you get 8. You differentiate 17, you get 0. So at the turning point, dy over dx is equals to 0. So 2x minus 8 equals to 0. When you solve that, you will get x equals to 4. And you substitute x equals to 4 in the original function, you get y equals to 1. So the minimum point is 4, 1. That means it doesn't go below 0, because the minimum point is 4, 1. For question number 2, if I add 3 to a number and square the the result is greater than the square of the original number. State given a reason if the above statement is always true, sometimes true, or never true. So you add 3 to a number, let that number be x, add 3 to the number and square it. And it says the result is greater than the square of that number. So let's test with some numbers. Let's use minus 5. Minus 5 plus 3 squared gives you 4. And minus 5 squared is 25. So 4 is not bigger than 25. So in this case, it is not always true. Choose another number. Choose 5. 5 plus 3 squared. 5 plus 3 is 8. 8 squared is 64. Whereas 5 squared is 25. 64 is greater than 25. So it is sometimes true. Because in this case, it is true. Question number 3. Given that the point A has position vector 4 minus 5j and the point B has position vector minus 5i minus 2j, find the vector AB. We now have A written as a column vector, 4 minus 5. B written as a column vector, minus 5 minus 2. Now we want to find AB. So to go from A to B, we want the second one OB minus OA. Remember, the second one minus the first one. So it's OB minus OA. So that's OB there, minus 5 minus 2. OA is 4 minus 5. When you subtract them, minus 5 minus 4, it gives you minus 9. Minus 2 minus minus 5, the minus and minus becomes a plus. It looks like 5 minus 2, which is 3. Now you can write it as minus 9i plus 3j, and that is AB. Part B, find the magnitude of AB. Give your answers as a simplified surd. Simplified surd, so that means no decimals. So you want to get minus 9 squared plus 3 squared and square root of that using this formula for magnitude. That will give you 3 root 10. You put that in your calculator. As a simplified surd, that's what you would have. A surd would have the square root with it. Do not use decimal. Question number 4. The line L1 has equation 4y minus 3x equals to 10. The line L2 passes through the point 5 minus 1 and minus 1, 8. Determine giving full reasons for your answer whether lines L1 and L2 are parallel, perpendicular, or neither. Parallel, that means they have the same gradient and they never meet. So these two lines are parallel. Gradient is the same. M1 is equals to M2. Perpendicular, they meet at 90 degrees. So the gradient of M1 times the gradient of M2 is equals to minus 1. Right, let's find the two lines. The first one, 4y minus 3x equals to 10. Arrange it to look like y equals to mx plus c. So we'll take minus 3x to the right. It becomes plus 3x. So it becomes 3x plus 10. It's times 4. We go take it to the right. It becomes divided by 4. So 3x divided by 4 and 10 divided by 4. So the gradient for line L1 is 3 over 4. That's like this m there. So that's the gradient for line M1. To get the gradient for line L2, we use this formula. M is equals to y2 minus y1 over x2 minus x1. So y2 is 8. Y1 is minus 1. X2 is minus 1. X1 is minus 5. So 8 minus minus 9, 1, it gives you 9. Minus 1 minus 5 minus 6. And that will be simplified to minus 3 over 2. So the gradient for L1 is 3 over 4. The gradient for L2 is minus 3 over 2. Those two gradients are not the same, so they are not parallel. They are not equal, so they are not parallel. Are they perpendicular? Let's check. m1 times m2, 3 over 4 times minus 3 over 2. It gives you minus 9 over 8. So it does not give you minus 1. So they are not perpendicular. So they are neither perpendicular nor parallel. Question number 5. A student's attempt to solve the equation 2 log x to the base 2 minus log square root of x to the base 2 is equal to 3 is shown below. Identify 2 errors made by this student, giving a brief explanation of each. First error, you cannot use the subtraction law without dealing with this 2 first. So they have to take these 2. These 2 in front has to go to the front there, so it'll be x squared before you use the subtraction law. So the 2 has to go to the front, so it'll be log x squared to the base 2 before you use the subtraction law. The second thing they did wrong was they undo the logs incorrectly. It should be x equals to 2 cube, which 2 cube is 8. You have here x is equals to 2 cube. So 2 to the power 3 should be equals to x, not the other way. So it should be 2 cube. X equals to 2 cube, not 3 squared, which is wrong. Those are 2 mistakes they made. For question 5b, it says write out the correct solution. So we first of all take that 2 to the front, it becomes x squared. They call it power to the front law, minus log square root of x over 2. Now we can combine them. When you subtract them, you divide those 2 together. So x squared divided by square root of x. Now we have 2 to the power 3 is equals to x squared over square root of x. So x squared divided by square root of x, you can write it as x squared times x to the minus a half, because x to the square root of x comes to the top, the numerator part, and then it becomes minus a half. So that means 2 minus a half. 2 minus a half gives you 1.5, which is 3 over 2 is equals to 2 cube. Now, the opposite of 3 over 2 is 2 over 3. So if we take that to that side, it will be 2 cubed to the 2 over 3. And this 3 can cancel. You have 2 squared, and that will be 4. So you can use your calculator to simplify that if you want. 2 cubed to the power 2 over 3. Question number 6. A company makes a particular type of children's toy. The annual profit made by the company is modeled by the equation. Part A, explain why £15 is not a sensible selling price for the toy. So for 6A, P is equals to 100 minus 6.25 bracket x minus 9 squared. We substitute x equals to 15. So when we substitute x equals to 15, put that in your calculator, you get P to be minus 1.25. It is not sensible as a company would make a loss of 125,000 because it is a negative. You're making a loss. For part B, the profit has to be bigger than 80,000. So we use P to be greater than 80. So that's where we put bigger than 80. And that is P there. We want P to be bigger than 80. So that is P there, all of this in the circle. And we want it to be bigger than 80. And we need to solve that. So if we take 100 to the right-hand side, 80 minus 100, it gives you minus 20. And then we divide by minus 6.25. When you divide by a negative, you change the sign from greater than to less than. Because we are dividing by minus 6.25, we change the sign from greater than to less than. And that will give x minus 9 squared is less than 3.2. So we take the square to the other side. So x minus 9 is less than square root of 3.2. So if we add 9 to both sides, that means 9 minus 3.2 less than x less than 9 plus 3.2. So that's how you will do that part. And for part C, maximum profit is equals to 100,000. Selling price is equals to £9. So if we have P is 100 minus 6.25 bracket 9 minus 9 squared, that gives you 100 minus 6.25 times 0, which this will be 0. So you got P to be 100. So if you plot that on your graphics calculator, x minus 9 all squared is that U shape, and y equals to square root of 3 is that green line. And you can see where they meet there, 10.31, and y is 1.7. And that's what you use for the x and the y axis view window to see it clearly. And you can also plot y equals to 100 minus 6.25 all bracket x minus 9 squared. So you would see here that maximum point when x is 9 and y is 100. So when x is 9, you get y to be 100. And that's what you put for the view window so you can see it clearly. Question number 7. In a triangle ABC, side AB has length 10 centimeters and AC has length 5 centimeters. Angle BAC is theta. Find the two possible values of cos theta. So we're going to use this formula. Area is half A times B sine C. So we have 15 is the area, is equals to half times 10 times 5 sine of the angle. So if you put that in your calculator, you would get sine theta equals to 3 over 5. Because 2 times 5 is 50. 2 times 15 is 30. 30 divided by 50. 10 times 5 is 50. It gives you 3 over 5. Now, we know cos squared theta plus sine squared theta is identical to 1. And 1 minus sine squared theta is cos squared theta. So we have cos squared theta is 1 minus sine squared theta. And sine theta is 3 over 5. So it's 1 minus 3 over 5 squared. So cos theta would be plus or minus square root of 1 minus 3 over 5, which would give us plus or minus 4 over 5. So which are the two possible values of cos theta? Given that BC is the longest side of the triangle, find the exact length of BC. So we use the cosine rule and then use the negative value of cos theta minus 4 over 5, or use obtuse angle, or find BC using cos theta equals to 4 over 5, and also cos theta is minus 4 over 5, and then choose the larger value. So those are the different options we can do. Let's do it. We have the cosine rule written down. A squared equals to B squared plus C squared minus 2BC cos A. So BC squared is 10 squared plus 5 squared minus 2 times 10 times 5 times we're using the minus version of cos theta. So that means BC would be square root of 205. And so we say the larger value is chosen. We can have BC squared is 10 squared plus 5 squared minus 2 times 10 times 5. And we use the positive value of cos theta. And BC would be square root of 45, which is the smaller value. Question number 8. A lorry is driven between London and Newcastle. In a simple model, the cost of the journey, C pounds, when the lorry is driven at the steady speed of V kilometers per hour, is given by that expression. Find, according to this model, the value of V that minimizes the cost of the journey. So we want to, when you say minimize, we want to find dc over dv equals to 0, the minimum. So we write C as 1,500. Take the V to the top. It becomes V to the minus 1 plus 2V over 11 plus 60. We differentiate dC over dV because it is C with respect to V. dC, differential of the cost with respect to V. So you differentiate V to the minus 1. Minus 1 comes to the front. So it's times minus 1, subtract 1. So it comes minus 1,500 V to the minus 2. Plus differential of 2 over 11 V is just 2 over 11. Differential of 60 is 0. Now we put dC over dV equal to 0 since we want to minimize, find the minimum. So we put that expression equal to 0. If we take minus 1,500 over V squared to the other side, we got 1,500 over V squared equals to 2 over 11. And we can cross multiply. 1,500 times 11 is equals to 2 times V squared. So that means V would be square root of 1,500 times 11 over 2, which will give you 90.8 kilometers per hour. For 8 part 2, we will substitute V is equals to 90.8, which we got from A. So our C would be 1,500 over 90.8 plus 2 times 90.8 over 11 plus 60. And that will give us a minimum cost of 93 pounds and 3 pence, 93.03. For part 3, dC over dV is this expression there. Now we differentiate the second time. D squared C over dV squared. When you differentiate, you times by the power, you times by minus 2, and then you minus 1. So the minus 2 times minus 1,500 to the minus 3. When you differentiate 2 over 11, you get 0 because it's just a number. So take the V to the minus 3 to the denominator, it becomes 3,000 over V cubed because minus 2 times minus 1,500 is 3,000 over V cubed. And when you substitute V, it's 90.8, which we got from there, 90.8 in there. So 3,000 over 90.8 cubed, it gives you 4.007 times 10 to the minus 3. And when you do that, you get a positive answer. So d squared y over the x squared is greater than 0. So you get a minimum. So we are using C here and V. So it will be d squared V over d squared C over dV squared is greater than 0. So that means d squared C over dV squared, you can write it as 0.0004, which is greater than 0 because positive. Hence, it's a minimum cost. For part C, it would be impossible to drive at this speed over the whole journey. Over the whole journey, the speed will change. And in your calculator, if you have table setting, you have 60. You start at 60. You end at 110. You go in steps of 5. And I'll show you what you do with that. And then you can have a table that will show you at 75, you get 93. At 80, you get 93.2. At 85, 93.1. And then at 90, you get 93.03. That's the one we're interested in, at 90. And that's the function you enter in the calculator.